Let's talk about hardware protection, which refers to the security measures implemented at physical level of a computer system to safeguard against unauthorized access, tampering, and theft. This involves protecting both the physical components of the device and the data stored on it. So, let's talk about few terminologies, starting with physical security, which involves protecting the device from theft, damage, e.g. environment factors like dust or overheating and unauthorized access. Then we have hardware-based security features, which is utilizing features like secure enclaves, hardware security modules, and trusted platform modules to enhance security. Then we have tamper-evident and tamper-resistant packaging, ensuring that the hardware components are protected from physical manipulation. Also have access control, implementing measures like physical locks, biometric authentication, and access control lists to restrict access to hardware. Then we have secure storage, using hardware-based encryption and secure storage mechanism to protect sensitive data. And then we have secure boot, which shows that ensuring that the system boots from a trusted, verified operating system. Then we have monitoring and auditing, which involve implementing systems to monitor hardware usage and detect potential security breaches. Talking about hardware protection technologies, we are starting with secure enclaves, which shows isolated regions of memory within a processor that are protected from various access by other software. Then we have hardware security module, dedicated hardware devices that generate, manage, and store cryptographic keys. Then we have trusted platform modules, secure cryptographic processors that store cryptographic keys and perform cryptographic operations. Then we have biometric authentication, using fingerprints, facial recognition, and other biometric data to authenticate users. Then we have hardware firewalls, dedicated devices that filter network traffic to protect against unauthorized access. We have secure processors, designed with built-in security features to protect against various attacks. Importance of hardware protection are data security, which protects sensitive data from being compromised or stolen. We have system integrity, which ensures that the system operates as intended and is not tampered with. We have availability, which protects against denial of service attacks and ensures that the system remains operational. Then have compliance, which helps organizations meet regulatory requirements related to data security. Then cost saving prevents data breaches and security incidences, which can be costly to recover from. More about that, we are talking about hardware protection and types of hardware protection. So we have three categories of hardware protection. The first one is CPU protection, then we have memory protection and input-output protection. Let's start with CPU protection. CPU protection ensures that a process does not monopolize the CPU identifiably, as it would prevent other processes from being executed. Each process should get a limited time so that every process gets time to execute its instruction. To address this, a timer is used to limit the amount of time which a process can occupy from the CPU. After the timer expires, a signal is sent to the process for relinquishing the CPU. Hence, one process cannot hold the CPU forever. Then we have memory protection. In memory protection, we are talking about that situation when two or more processes are in memory and one process may access the other process's memory. To prevent this situation, we use two registers, which are known as base register and limit register. So basically, base register shows the starting address of a program and limits registers to the size of the process. This is done to ensure that whenever a process wants to access the memory, the OS can check that is the memory area with the process wants to access is privileged to be accessed by that process or not. So, input-output protection. With input-output protection, an operating system ensures that termination or input-output of other processes. This means one process should not be able to terminate input-output operation of other processes. View input-output of other processes. One process should not be able to access the data being read or written by other processes from to the disk. Then, giving priority to a particular process input-output. No process must be able to prioritize itself for other processes which are doing input-output processes other than processes. So, more on hardware security. I hope you're enjoying the presentation as we are diving more into it. So, thank you so much for staying tuned. So, we are doing well so far. So, we are going to see a few stuff here we are supposed to discuss on hardware security, its definition, threats, and best practices. So, what is hardware security? Hardware security is the process of physical device from threats. Protection is the protection of physical device from threats that will facilitate unauthorized access to enterprise systems. So, hardware security is the domain of enterprise security. Hardware security is a domain of enterprise security that focuses on protecting all physical devices, machines, and peripherals. This protection can be in form of physical security such as guards, locked doors, and CCTV cameras. It can also be in form of a dedicated hardware component such as integrated circuit that provide cryptographic functions for protecting the hardware from security vulnerabilities and deflecting attackers. Simply put, hardware security involves protection through physical devices or operations rather than security programs such as antivirus. So, in terms of physical security, hardware security essentially entails protecting on-premise systems from natural or human tampering or destruction. This is especially necessary as attackers targeting computing as well as non-computing connected devices such as machine-to-machine or Internet of Things environment are becoming more prevalent as their adoption increases. So, a common example of hardware security is a device that scans employees' endpoint or monitors network traffic, such as hardware firewall or proxy server. Device-based hardware security is also achieved through hardware security modules. So, devices that generate and help manage cryptographic keys for the authentication and encryption of enterprise systems. Such hardware systems allow companies to add another layer of security to sensitive architectures. While software-based measures exist to secure nearly all enterprise environments, the use of hardware-based security is advisable in the case of architecture responsible for the connectivity of a large number of hardware devices. So, security gaps can be exploited when the hardware receives input, runs code, or engages in any operation. Any device that connects to a network, either directly or indirectly, needs to be protected from attacks. Even seemingly an important system such as smart lighting solution can be targeted by attackers to impact productivity. Important hardware such as servers and employee endpoint require robust security measures to ensure smooth daily operations. Threat actors Just threat actors may also operate from within an organization, making the drafting and enforcement of solid internal hardware security policy as important. So, 10 key threats to enterprise hardware. Firmware, basic input-output, motherboard, network cards, Wi-Fi cards, hard drives, graphic cards, systems on chip, and servers are listed as goals. An organization is the sum total of its hardware devices, and each of these come with their own vulnerabilities from the component level. So, key enterprise hardware threats: we have outdated firmware. Not every company in the smart devices segment is an expert in IT security. For instance, local manufacturers of Internet of Things and Internet of Things components such as smart HVAC, connected RFID, access, and plant robotics might provide firmware full of bugs and other security flaws. Careless patch management can lead to further complications and the creation of new vulnerabilities. Then we have inadequate encryption. Another one is an unsecured local access, unchecked default passwords, vulnerable customized hardware, backdoors, eavesdropping. Then we have modification attackers triggering faults in counterfeit hardware. So 7 best practices for hardware security. Study your hardware supplier, and then you encrypt whatever you can. Implement adequate electronic security, minimize your attack surface, then ensure robust physical security. Yeah, I think those are the few that we can. Then you have to conduct regular audits, implement a real-time monitoring. That's what you can do. So, more about hardware security, we have to check a few here as we are winding up. We have types of hardware security threats. We have lack of encryption, as you've already said, backdoors, man in the middle attacks, we have password attacks, we have eavesdropping, outdated firmware, counterfeit hardware, unsecure local access, physical attacks, side channel attacks. Then we have hardware trojans and raw hammer attacks. Why engineers should care about hardware security? As we keep progressing in the engineering niche, cyber criminals are getting smarter, and if care is not taken, they can destroy the good works in various sectors. So a few as follows: stabilize data protection, enhance integrity, reduce hardware vulnerability, establish defense against cyber threats. Okay, so how to protect embedded systems? To protect your device from hardware security threats, you need to combine both hardware and software strategies. Here are some general steps you may consider to improve the security of embedded systems. One is authenticate the secure boot process of your device. Use digital signatures to verify your firmware updates. Use firewalls and secure communication protocols such as TLS and SSL to protect your network connection. Encryption. Encrypt your data with strong passwords to prevent the leakage of sensitive information. Employ memory protection techniques such as address space layout randomization to guard against attacks like raw hammer that target DRM, direct RAM. Use hardware security modules to protect your cryptographic keys from hackers. I hope I have actually spoken each and every point I was supposed to say here. See you next time.